Good day everyone and welcome to another video of HALINA'T MATH-TUTO sa Dasmariñas North National High School TV. I'm Ma'am Eva, your teacher lecturer in this video. Our topic in this video is about permutation. And the objectives of this video are the following. Illustrate permutation. Find the permutation of n objects taken R at a time, and solve problems involving permutation. But before that, let us consider this problem. Mark invited his close friends Oriel, Gian, and Paul on his birthday. He prepared chairs placed in a row to be occupied by his friends. The questions are, list all the possible seating arrangement. In how many ways can they be seated in a row? For us to answer number 1, we're going to list down all the possible seating arrangement like this one. Therefore, there are 6 ways of arranging the chairs. This method is what we call systematic listing. Another way is by making a diagram like this one. Therefore, there are 6 ways of arranging the chairs. And this diagram is what we call tree diagram. Another way of answering the question is by fundamental counting principle. We have here 3 boxes because there are 3 chairs. For the first seat, we're going to put 3 because there are 3 possible persons to be seated in the first seat. For the second box, there are only 2, and for the last one will be 1. And we will multiply this one, and the answer will be 6. And aside from fundamental counting principle, we can use permutation to answer that problem. And what is permutation? Permutation is arrangement of objects in which order is important. Each arrangement can be made using all or some elements of the set of objects without repetition. Examples: choosing possible passwords for your GCash, arranging 6 potted plants in a row, and arranging 5 people in a row for picture taking. Now, 3 times 2 times 1 is equal to 6 can be written as 3 exclamation mark is equal to 6, or 3 exclamation mark is read as 3 factorial. And what is factorial? If n is a positive integer, then n factorial denoted by n factorial is the product of all integers less than or equal to n. Therefore, n factorial is equal to n times the quantity n minus 1 times the quantity n minus 2 times the quantity n minus 3 times the quantity n minus 4 times the quantity n minus 5 and so on times 2 times 1. Let's have an example. Compute 6 factorial. Our solution will be 6 factorial is equal to 6 times 5 times 4 times 3 times 2 times 1. And that is equal to 720. Another example, compute 7 factorial divided by 4 factorial. Solution, 7 factorial divided by 4 factorial is equal to 7 times 6 times 5 times 3 times 2 times 1 divided by 4 times 3 times 2 times 1. Then, we're going to cancel out 4 times 3 times 2 times 1. Then we will have 7 times 6 times 5. Therefore, 7 factorial divided by 4 factorial is equal to 210. Let's have another example. Using the letters from the word English, how many 7-letter patterns can be formed? For our solution, English has 7 letters. Therefore, we will have 7 factorial. 7 factorial is equal to 7 times 6 times 5 times 4 times 3 times 2 times 1. That is equal to 5,040. Therefore, there are 5,040 7-letter patterns. Now, for permutation of n objects taken R at a time, that is, if a set of n elements, then the number of ways drawing R elements from the set is denoted by permutation of n taken R at a time, or we have P of n taken R at a time, or permutation of n taken R at a time. The number of permutation of objects taken at a time is given by the formula permutation of n taken R at a time is equal to n factorial divided by the quantity n minus R factorial. Let's have an example. The 7 high school cheerleaders are to have their pictures taken. How many different pictures can be taken if there are to be 3 cheerleaders in each picture? Find the number of permutation of 7 people taken 3 at a time. So for our solution, the given is 7 high school cheerleaders. The question in our given problem is that how many different pictures can be taken if there are to be 3 cheerleaders in each picture. Therefore, we're going to find the permutation of 7 people taken 3 at a time. That is written as permutation of 7 taken 3 at a time. We are going to use the formula for permutation, that is permutation of n taken R at a time is equal to n factorial over the quantity n minus R factorial. We're going to substitute the value of n, that is 7, and R, that is equal to 3. We now have the permutation of 7 taken 3 at a time is equal to 7 factorial over the quantity of 7 minus 3 factorial. That is equal to 7 factorial over 4 factorial. 7 factorial is equal to 7 times 6 times 4 times 3 times 2 divided by 4 factorial, and 4 factorial is equal to 4 times 3 times 2 times 1. We will cancel out 4 times 3 times 2 times 1, and we will now have 7 times 6 times 5. Therefore, the permutation of 7 taken 3 at a time is 210, and there are 210 ways. And that's it. Thank you for watching, and I hope you learn it. Don't forget to LSS, like, share, and subscribe to our YouTube channel, HALINA'T MATH-TUTO, and see you on the next episode of HALINA'T MATH-TUTO sa Dasmariñas North National High School TV.